Guys, we're going to do binomial probability day 2. This is unit 11, lesson 7. Today we're going to be concentrating on mutually exclusive events, and the definition of a mutually exclusive event is, in logic and probability theory, two events are mutually exclusive if they cannot both occur at the same time. The best example of this is the outcomes of a single coin toss, which can result in either heads or tails, but not both. So if you listen to the last lesson we did, we were talking about something exactly happening, like occurring exactly 4 times, occurring exactly 5 times. So today we're going to concentrate on when events happen, and it might happen at least 4 times or at most 6 times. So that's what we're going to concentrate on today. So the formula kind of looks similar, and it's going to seem a little bit similar, but we're gonna tweak it a little bit. So it says Jenna is taking a 5-question multiple choice quiz where each question has 4 choices on it. If she randomly guesses at each question, determine the probability she correctly answers, here it is, at least 4 out of the 5 questions. All right, so let's see. First, we got to figure out how many trials are we doing. 4 out of, so there's 5 questions, right? So I have 5 trials. I want to correctly at least 4. So let's talk about at least 4. So at least 4 means I could have 4 correct questions or correct answers, or what else could I have? I could have 5 correct answers, right? Because at least 4 means 4 or more. Since there are only 5 questions, I can't get 6 questions correct because there's only 5 questions on the test. So the probability of me getting 4 questions correct out of 5 trials, well, let's see, what's the probability of getting a question correct? Well, there's 1 correct answer out of 4 choices, and I want this to occur 4 times. The probability of me getting an incorrect answer would be 3 out of 4. And if you remember, the exponents here have to total the number of trials, so that would be getting at 4 questions correct, plus I'm going to add the probability of me getting 5 questions correct. So that would be 5. I want to be successful 5 times. The probability of me being correct is 1 out of 4, or guessing there's 1 out of 4 correct choices. This is going to happen 5 times, so that means this would happen 0 times, because again, the exponents have to add up to the number of trials. So if you use your calculator, and again, you're going to hit the math button, go over to PRB. You're going to go down to choice 3, I believe it is, was NCR. Type this in your calculator, and you will get, all right, so if you correctly put this in the calculator, you get 15 out of 1024 plus 1 out of 1024. Which is 16 out of 1024, which then reduces to 1 out of 64. I cannot stress enough that when you go to school to practice these in class, really practice typing all the buttons in the calculator. We don't want to see any mistakes. If you know how to set it up, putting it in the calculator should be the easy part. On a tropical island, it consistently rains 40% of the days. Over the next 7 days, find the probability that it rains at most 2 times. So what do we got going on here? So this is important. This is my number of trials. My probability that it rains is 40%. Convert that to a decimal. And we want to know that it rains at most 2 times. Well, at most means that it could rain 0 times, that would be okay. It could rain 1 time. It could rain 2 times. So at most 2 times. Could it rain 3 times? Well, no, because that is more than that. So we're going to have to set up 3 different probability calculations here. So the probability that it rains 0 times would be the probability that it rains. We want this to occur 0 times. So if the probability that it's raining is 0.4, that means the probability that it is not raining would be 0.6, and we wanted that to happen 7 times. Plus, we're going to do the next probability that it would rain 1 day. So we're going to say 7 out of 1 day it's going to rain, so that would be 0.4. We're saying it can rain 1 day. it cannot rain 6 days, plus the probability that it could rain 2 days, 0.4 raised to the 2. And then if it rains 2 days, that means that it would not be raining 5 of the days. So if you put these numbers in your calculator individually, this number becomes 0.2799 and a bunch of numbers after it, plus 0.1306 plus 0.2612. You get a total of 0.419904. And it says, oh, it didn't tell us how to round, but we're going to go ahead and round to the nearest 10th. We'll round to the 100th. Okay. All right, so now they're talking about a compliment, and they're not talking about saying nice things to someone else. Sometimes what happens is it's easier to think about this from another point of view. So before I get into the definition, let's look at the example and see if we can figure this out. A fair coin is flipped 10 times, and the outcome is recorded each time. Let E be the event of getting at least 2 heads on the 10 flips. So this number here, this is our trials. So we have 10 trials, and they want us to get at least 2 heads on the 10 flips. So getting at least 2 heads means I could get 2, I could get 3, get 4, 5, all the way up to 10. So if you're looking at this, this would be a large calculation to do, because I would have to do an individual calculation for 2, for 3, for 4, for 5. It's easier to do the calculation for 0 and 1, take that value and do 1 minus that value for 0 and 1, instead of doing a calculation for 2, 3, 4, 5, 6, 7, 8, 9, 10. So okay, so let's see. Let's take a look. What is the complement of this event? So the complement would be the probability of getting less than 2 heads. Right, so that's what I was saying, was if you got 0 or 1, find the probability of the complement of E. So that would be 1 or 0, right? So let's set that up. So we would have 10. Choose 1. The probability of being successful is 1/2 raised to the 1. And then we have 1/2 raised to the 9th. Plus, we would then have to take the probability of 10, choose 0, 1/2 raised to the 0, 1/2 raised to the 10th. If you do these calculations, you get 11 out of 1024. Use your answer from B to determine the probability of E. So this is where we were saying before, we're going to take it from the opposite direction. Instead of calculating 2, 3, 4, 5, 6, 7, 8, 9, 10, we're going to calculate the not part, and then 1 minus 11 over 1024. You get 1013 out of 1024. So to the nearest 10th of a percent, what is the probability of getting at least 1 head on 4 flips of a fair coin? So let's see. At least 1 head on 4 flips of a fair coin. Well, that would happen 1 or 2 or 3. But instead of doing all of those calculations, I could do this one. And then I could take that value and 1 minus that value. And I get 15 out of 16. So again, if you calculated the probability for being successful 1 time or 2 times and then 3 times and then added up all those values, you would get 15 out of 16. Or you could do it the reverse way. Calculate less probabilities and do 1 minus that value. A carnival game is created where contestants throw bags at the board shown below, which consists of 4 congruent triangles, one of which is painted black. A contestant pays $3 for 2 bags and will win if at least 1 bag lands in the shaded area. Assume that the bag always falls in the overall area. Okay, what is the probability that a bag will land in the shaded area? Well, I see 4 triangles. I am successful when it hits the shaded triangle, so there is 1 shaded region out of 4 possible regions. So the probability that a bag will land in the shaded region is 1/4. Determine the probability that Joshua wins the game if he plays it once. Well, let's go back up and see. So a contestant pays $3 for 2 bags. So I get 2 bags, so I get 2 chances every time I play this game. Well, and I am successful if at least 1 bag lands in the shaded area. So if I have 2 bean bags to throw and I have to be successful at least 1 time, I could be successful 1 or 2 times. Right? So the probability of me being successful 1 time would be 2, right? 2 trials out of 1. The success rate is 1 out of 4. That's going to happen 1 time. I'm going to be unsuccessful. The probability of being unsuccessful is 3 out of 4, and that's going to occur 1 time. Plus, I'm going to have to add the probability that I am successful both times. So the success rate is 1 out of 4. I want that to happen 2 times, and if you want, you can do this. I am unsuccessful 0 times, which we know anything raised to the 0 is 1. So when you calculate these probabilities, add them up, you get 0.4375. Convert that to a fraction is 7 out of 16. If Joshua plays the game 3 times, what is the probability he will win at least once? Round your answer to the nearest percent. All right, so let's go back. When I'm playing this game, I get 2 bean bags or 2 whatever things I'm throwing. So if I play this game 3 times, there will actually be 6 trials. And I want to be successful at least once. So if there's 6 trials and I need to be successful at least once, that means I could be successful 1 time or 2 times or 3 times or 4 times or 5 times or 6 times. I don't know about you, but that seems like an awful lot of work to calculate the probability of being successful once, adding it to the probability of being successful twice, adding it to the probability of being successful 3 times, so on and so forth. Or I could come from the reverse direction. I could calculate the probability out of 6 trials that I am successful 0 times. Well, the probability of me being successful is 1/4. I want that to happen 0 times. I'm going to be unsuccessful 3 out of 4 times, and I want that to happen 6 times. When I calculate that probability, I have 729 divided by 4,096. And then I take that value, 1 minus that value equals 3367 out of 4096. All right, so, and again, the reason why we chose to do it, this method 1 minus the probability of the, was because it's a lot of calculations to have to do this, right? So when you're reading these and it seems easier to come from the opposite direction, I would do it that way. So again, today we studied mutually exclusive events, and we talked about the key thing, the key words were here was at most or at least. So I would strongly encourage you to write out the number of outcomes that are possible, and it's going to kind of help you just set up your problem. All right, thanks for tuning in. Hopefully you had a good time and have a good night.